Yeah.
Hello.
Hello, good afternoon, sir.
Yeah, yeah. Good afternoon.
Good afternoon, sir. Sir, shall we start?
Yeah, yeah.
Uh, Good afternoon, participants. On behalf of organizing committee, welcome you all to the second session of day two of ISEA-sponsored 5-day online short-term course on cybersecurity, managing risk in the information age. Our speaker for the day has already joined. Let me give a brief introduction of sir. Uh, it is a great pleasure for me to introduce the speaker of the session, Dr. Pillai Emmanuel Shubhankar, who is going to talk about security and privacy in blockchain. We wholeheartedly welcome you, sir. Dr. Pillai obtained his PhD degree from IIT Roorkee and MTech degree from BIT Ranchi. Presently, sir is working as an associate professor in the Department of Computer Science and Engineering at NIT Jaipur. He has 24 years of teaching, research, and administrative experience. He has, to his credit, more than 30 research papers in international journals of repute and more than 70 research papers in international conferences. 14 PhD degrees have been awarded under his guidance. He is currently guiding many doctoral and MTech research scholars. His area of research is security, privacy and forensics, cloud computing, big data, Internet of Things, blockchain and quantum computing. Sir is an honorary dean, network and hardware in Rajasthan ILD Skill University, Jaipur. Sir is a senior member of both IEEE and ACM. He is also a member of Cloud Computing Innovation Council of India, Quantum Ecosystem Technology Council of India, and Digital Forensic Research Workshop. Sir is also in the reviewer panel of many international journals of repute. Now, I would like to request Sir to please take over the session. Sir, please.
I think the sharing access is not there. Can you just?
No, sir. Now you can share. You are a presenter now.
Yeah, the sharing option is not coming yet.
Vikas sir.
Yes, now he is presenter, sir.
अभी भी वो disabled दिखा रहा है.
Vikas sir, again remove sir from the presenter list and again make him presenter.
नहीं कोई किसी और इमैनुअल को बनाया आपने, इमैनुअल राज गोसाला को बनाया. इमैनुअल पिल्ली रहेगा, देखिए पिल्ली सर्च करिए.
Yes.
पिल्ली PILLI.
PILL. Yes sir. Wait a minute. Now sir change room.
Yes. आगे. Thank you. Yeah, आपने पहले भी करा था, but it was somebody else. Right, no problem. Yeah, thank you so much for inviting me here for NIT Jalandhar, and I've in fact it's a privilege because I've come many times and also interacted multiple times with faculty there, and it's a privilege that I'm here again sharing some thoughts on again as we look at security issues and privacy issues in blockchain. I see a lot of people here in this meeting today, so I was very happy to see so many of you inside this meeting and trying to listen and understand. So here my thought actually comes from trying to understand the basic interest in blockchain. In fact, if you look at, I was surprised to see that there are no sessions on blockchain, but then again, blockchain itself involves a lot of security, a lot of hashing, a lot of cryptographic codes, and the internal structure is as such. But anyway, today I'm not really going into the internal structure. I will give you a brief understanding of what a blockchain is. Some of you may not have really worked anything on blockchain, so brief introduction I'll give you, and then take you through some of the challenges which are happening, and through some literature that is also there. So we'll try to look at what best can be done, right? So in the time that is there with us. So these are some words as we look at when we look at blockchain and a variety of words that come. One of the words that should strike us is what is called a ledger, or digital ledger, or open ledger, or the basic idea it is called is digital ledger technology, DLT. Is what we are considering, and then of course the word cryptocurrency actually goes for us, but cryptocurrency is basically a means of how the things became popular, and why it came into picture was because of cryptocurrency. But if you look at it now, blockchain is used in multiple ways, right? So one of the strong aspects of blockchain, if you look at it, is to store some information in a very trustworthy manner, right? So some of the data that is stored on the blockchain, blockchain simply understood, it is a chain of blocks. So when you look at this chain of blocks, the chain of blocks holds some information like a linked list. You can think of blockchain is a chain of blocks like a linked list, and linked list has a structure where you store the information, and information when we used to do data structures, it was a simple an array field or an integer variable or a floating point variable or whatever, one data type, right? But then of course you can store a record also. In fact, you can store a transaction also. When we look at blockchain and we call it, it's a distributed ledger technology. Ledger, maybe many of you would have heard in the banks, right? So when you look at banks and you try to understand how it looks like. So in a bank, Of course, again, you would not have seen a ledger in a bank, a ledger book in a bank, right? Earlier, maybe when I was doing my engineering at that time, whenever we used to go to the bank, they used to enter a ledger book. They used to open like a dictionary. They used to open, account numbers are arranged in ascending order, obviously. So you would open it like a dictionary, how you'll open, and then you will go to the exact bank account, and then you'll write down this thing. So later it was digitalized, and now we have what is called your internet banking account. So you log into your internet bank account, you have the password, and then you get a that whole statement. That is a ledger. That is what you can simply understand. The income and expenditure, it becomes a ledger. So now this ledger, when it is public, right? So that becomes your distributed public ledger is what is there. So public ledger. Now having a internet banking account showing you the bank statement, that is very fine because it's a ledger. But if you want to make it public ledger, then you will be not happy because the public ledger will talk about the ledger going public in the sense that anybody can see the statement. Then you will not be very happy. But then the basic idea is that it is a public ledger because anybody can see. So blockchain, the cryptocurrency transactions can be seen by anybody. So that is something surprising. Now, why do we want all the transactions to be shown in public? Is something which is very important. So you would not like, right? You would not like your ICICI bank statement or HDFC bank statement to be seen by anybody. But you would not mind if everybody can see the statements, but nobody knew whose bank statement it is. So that is the beauty of blockchain. Blockchain is actually storing a lot of transactions, but these transactions are made by different individuals. But some tags of that information is there, tagging, maybe a number, maybe a code is there. Again, it's a crypto code, right, or a digital code or a hash code, right, of that particular individual is there, but name or location or no other details is there. Like you have a KYC which is done when you join a bank account. Here there is no KYC, right? So then there is no problem. I can put my ICICI bank account online. I have no problem as long as it doesn't tell me that this account belongs to Emmanuel Pili and this is his bank account, this is the address, right? So even bank account also is a problem, but the bank account is also other encoded as a hash value. I have no problem because nobody can look at the hash value and understand what is my bank account. Right, so that is something which blockchain does. So now we'll try to understand what is the importance of blockchain, because blockchain keeps the data secure. Whatever all these transactions, once they are approved and added to as a block, now once the block is set, then you cannot change the transactions. So like that, if you put any value which you want to fix it and it is trustworthy, then it cannot be changed. So that is what blockchain can help you in. So maybe some of you would have used what is called DigiLocker. DigiLocker is an app. Maybe you can go and of course there may be a web interface also. I use a app on my mobile, and I have placed most of my government records. I have fetched there and put it like my driving license, like my RC book, the registration copy of my vehicles, and of course Aadhaar card and all. So I could fetch it from governmental databases and I could fetch it and put it into that. So DigiLocker. So even if I don't carry a hard copy, some days the police catches me and then they ask me for the driving license, I open the DigiLocker and show them. If somebody at the airport sometimes proof they want, so I show that soft copy and they allow me, because DigiLocker is a government setup. So now what is happening? All my data is coming in and it is made available by us, right? So by the government, and we are able to show it on the app, right? So that is a kind of trust that can be created, right? It cannot be changed. You cannot bluff it. Some data that I want to present, only my data I can download. I cannot download somebody else's Aadhaar card into my DigiLocker because it is all linked with the telephone number, right? Your Aadhaar card registration is with the telephone number, DigiLocker is with the telephone number. So the telephone number of course plays an important role in our lives these days, right? So anyway, let's look at, so it all started, Bitcoin started somewhere in 2009 when there is a person called Satoshi Nakamoto. You would have heard about this story, and immediately there was a story which was in times of London. They said that the chancellor bailing out banks. The basic idea of Bitcoins or blockchain was basically not to pay the transaction fee. Now, whenever you are making a transaction from city to city, no problem. Some 50 rupees, 100 rupees, you'll have to pay for the DD, right? You take a DD and send it. Online transaction, when you want to do, you pay some, 25 rupees, 50 rupees, depending on the bank. If it is from the same bank, they don't charge the money. If it is of another bank, they charge the money. So here is this. Let us think about sending money to abroad, or maybe to other countries like Singapore or maybe Pakistan or some other place where you want to send the money. So that's where the question comes: is you have to pay a huge amount of money. So this person who was interested in blockchain, he came up with this idea that let me avoid all transaction fee. Let me create another banking system, alternate banking system, where I build a currency and then I can make it viable. So that's how today you pay for $1, you pay 81 rupees, 82 rupees. I think something these days it's 82 plus, right? But if you look at blockchain, one Bitcoin, if you look at, the cost is something like 40 lakhs. I don't know, I have not checked what is today's cost, but something like 40-50 lakhs is one Bitcoin. So just imagine, how did it become so costly? How did it become so powerful? Is because of the usage and how it is being traded. So of course, why you want to use Bitcoins, or where Bitcoin became popular, you may be understanding. You may have, because you're all security guys, you may have heard about the aspect on what is called WannaCry, which was a spyware, and then it used to come and encrypt your system. Software, if you download that software by using, for maybe it comes as a good software, but when it comes inside, it encrypts your system. And later people said, if you want to decrypt the system, a mail would come to you. People knew who you were and all by looking at your system. Then that email would come and they would tell you, if you want to unlock and decrypt the system, then you will have to pay so much money in using Bitcoins. Why that was done? Because Bitcoins cannot be traced. If you are making transactions on the Bitcoins, it can't be traced. But of course, as of now, Bitcoin is not illegal in India. At the same time, Bitcoin is not a legal tender. Now, when you say what is a legal tender, today 500 rupee note is a legal tender, 2000 rupee note is a legal tender, but a 1000 rupee note is not a legal tender. Right? 2000 rupee note is legal, 500 rupee note is legal, but the 1000 rupee note is illegal. Illegal tender because it's banned. 1000 rupee notes are banned. So what is a legal tender? Bitcoin is not a legal tender. You cannot buy and sell in Bitcoins in India. You can't accept it, right? But then you can buy and sell Bitcoins, no problem, on another platform. That's called a Bitcoin exchange. You can go there, like how you go to a stock exchange and buy and sell stock. You can buy and sell Bitcoin. So in fact, if you look at it, Indian mindset goes with Bitcoin as a stock commodity. I buy Bitcoin today 30 lakhs, tomorrow it is 40 lakhs, I will sell it. I get 10 lakhs in no time. Right, so somebody who has 30 lakhs can obviously invest in a Bitcoin and then get some more money. Of course, people have lost money also because the rate went to 69 lakhs or something. People thought it will become 1 crore, but suddenly it came back to 40 lakhs. So they lost 20 lakhs. So like that also it is there. So be careful, study, and of course, it is not only Bitcoin now. There are so many cryptocurrencies you can try to look at, right? So basically, Bitcoin basically is based on solving an encryption formula. We'll try to understand that, but that requires extreme amounts of power, right? So whenever you solve the formula, you get some Bitcoins also. I will explain that, right? So the Bitcoin denominations are also there, like you have Paisa for a rupee. So you have milli Bitcoins, micro Bitcoins, and Satoshi. Satoshi Nakamoto is the author of a paper. Maybe you can look at that paper also. Bitcoin paper is there, which talks about Bitcoins, and then you can look at that paper, right, which talks about how the Bitcoins are created and generated. So that is by Satoshi Nakamoto, but we don't know whether Satoshi Nakamoto is an individual, because we don't know, we don't have an email, or we don't have his details, or where he is working, or any detail. He's just left that paper on the internet and it became so popular, and that's how these things have come in, right? So the 1/9th part is said to be a Satoshi, because you can buy and sell in Satoshis, because one Bitcoin is 40 lakhs, so you can't make a transaction. So if you want 1 rupee out of that, so now we'll have to buy in Satoshis, so you can make transactions in Satoshis, right? So if you want to access Bitcoins, or if you want to create a Bitcoin, so you can, or you want to get some Bitcoins, or any other cryptocurrency, maybe Ethereum or Monero, or any of these Ethers, or any of these cryptocurrency, if you want to, you can buy it from a Bitcoin exchange. You can buy it from a Bitcoin exchange using your rupees currency, fiat currency, what we say, Indian rupees. You can go and pay in Indian rupees and buy a Bitcoin from a Bitcoin exchange. Obviously, what you get is a code. right? So that is how you remember, and you can store it in what is called a wallet, like how you have a Paytm wallet or a Bitcoin, what do you say, GPay or Phone Pay or some of these wallets. You can put it there. It's called a software wallet, but of course, if somebody can steal the money, then you are at a loss. So you have to be careful whenever you are opening a Bitcoin exchange wallet. And then obviously you can have a hardware wallet where the code is supplied and the code can be placed and you keep it in your pocket, right? So whenever you want to use it, then again you have copy that code from that hardware wallet. Of course, hardware wallet also is a dangerous thing, because if you lose a hardware wallet, people can get hold of that data, right? You can have a friend who can transfer. If he has Bitcoins, you can transfer. And the last option is mine a Bitcoin. Mine a Bitcoin is where we were talking about, if you solve the encryption formula, you get some Bitcoins. So that is how you will get the Bitcoin. So we'll come to understand what that is, right? So let me move ahead. I think these are not, I will share the slide so you can look at that. So this is how a ledger looks like in the case of Bitcoin or any other Bitcoin. This is how a ledger looks like. So you have, this is the, I don't know what is the latest now, some more numbers would have come. I have one slide on that, so we'll see that shortly. So this is a sample snapshot taken some time ago, maybe August 2020. So don't worry about that. So this is a sample example. There we are talking about the number of blocks to be added. This number increases every 1 hour. 6 to 7 blocks are added. So every day, some 20 into 24 into like 6 blocks, let us say, or some 130, 150, let us say 150 blocks per day are added. Some 4,500 blocks are added per month, and somewhere around 60,000, 5 into some 50,000 blocks are added every year, right? So like that, these are the kind of things that are getting added, and there are some transactions which are stored in each block. And the size of the block, because the number of transactions will mean the size of the block, the KBs, MBs. So roughly about MB, 1 MB, 1.5 MB. And then what is the transaction fee? Again, I said initially there was no transaction fee, but then after these blocks started getting added, and I think the new Bitcoins that will be created will be soon exhausted. So what will be the motivation for people who will verify these transactions or maintain these transactions will be the transaction fee. As of now, 6.25 Bitcoins are being given, as we just saw. This is how the Bitcoins, initially it started with 50 Bitcoins and slowly it reduced to 25, then 12.5, now 6.25. Maybe another 4 years, May 2024, it may become 3.125 Bitcoins, right? So this is the latest picture that you can look at recently. So there was some, 7 lakh, the height has increased to that level. This is what is the hash that I was talking about. So initially starting few zeros will be there, some 19 zeros will be there, right? And after that you will have a number which is there. And you see in 1 hour, usually about 3 to 4 or 5, let us say how many, 2 hours if you look at it. So this is 1 hour. In a sense, 1, 2, 3, 4, 5, like something like 5, 6 Bitcoins are created every 1 hour, right? So this is how a block looks like, right? This is how a block looks like. The block has, the block hash. Block hash is usually some 19 preceding zeros. Okay, 19 preceding zeros followed by some number. So that is what is a block hash. And then the height of the block hash is the number of the block as we have seen, right? So that is fine. And then we have transactions, number of transactions here, there were 600, right? And then you have a nonce value, and then you have what is called a Merkle root, right? Merkle tree, you would have heard. Of course, it's beyond the scope of my lecture today. I may not be able to explain what is Merkle tree. I'll briefly explain what is Merkle tree. These are all, again, if you look at it, hashing, Merkle tree and nonce and calculating, solving a cryptographic puzzle. This is all cryptography. I am still not going to stop here, because first part of the lecture I will deliver how we'll go about it, and next part of the lecture is where I will look at privacy and security issues in blockchain. At one time when I tried to start studying, because my interest always goes like this. So I started with networks and then security, then I moved to cloud and then security, big data and security, Internet of Things and security. So I was initially wanting to start blockchain and then security. So when I looked at blockchain security, people laughed and people, were surprised. and they said, I don't think something like that will happen, or something like that can be thought about. So there is no point of why you should go into such a thing. So there's no point. Please don't think about that, right? So, but I put on, I looked at, I kept reading. Then slowly, literature started coming in privacy and security. One of my PhD students is working on privacy and security. So then I realized that there is a lot of work which is going to come, because any system that is working fine, and especially any system that is commercial in nature, will be attacked, will be compromised. If there is an intelligent fellow who is actually running a Bitcoin successfully, cryptocurrency or a blockchain successfully, there is going to be an equally intelligent or equally maybe more intelligent or more hardworking gentleman or a lady who can actually hack into this blockchain and get hold of that particular thing. So security on blockchain itself is built on security principles. So in fact, elliptical cryptography is what is used at the underlying things, right? So I will tell you certain things, and then you will be amazed at the computer science behind blockchain. So most of the time for us in Indian mindset, we are looking at the financial aspects of blockchain. If I invest this money, how much so when I tell I'm doing blockchain research, many friends call me and say, which blockchain should I invest? Then I said, I'm not the right guy, because I don't know what blockchain is giving you more money, because that's not my interest. My interest is how I can use blockchain to solve some more problems for humanity. Right. So, and then while I'm solving, there are some security concerns as well. So if somebody loses money, can I help him? So that's where my interest comes for in trying to understand the security aspect. So whenever you want to create, what you need to calculate is this new hash. What is the cryptographic formula that you have to solve is you have to calculate the new hash. How do you calculate the new hash? You depend on the previous block hash, like linked list, previous address, right? So previous address. So you can look at the previous block hash, and then you have what you call the Merkle root. Okay, I will explain what is Merkle root, and then you have to guess this value called nonce. Combining these three things, that is the previous block hash, the Merkle root. The Merkle root is built on the transactions. All these transactions build up what is called the Merkle tree, and the root of the Merkle tree will be what is called the Merkle root. The Merkle root, which is based on the transactions, the previous block hash, and a particular nonce value. This you have to guess, so that you will try to solve the problem and get a new hash, which again has some starting 19 zeros, right? And then some value, you get that. And if it is less than the target value is what is mentioned in the cryptographic principle. And once you solve that, whoever solves it first can add the block, and whoever adds the block first gets the reward, right? So the reward is also mentioned here. So that is something, it's not mentioned in the block, it is mentioned in the things, right? So that is how you can look at, right? So these are some transactions as I looked at. So you have a transaction hash where you want to send these are the persons who want to send the 32-bit ID you can look at, or 32-bit hash code. What is the amount that they are sending, whom they are sending to. So a group of addresses can be sent to a group of individuals. So sometimes some of these addresses belong to the same individual, right? And he's sending a set of money, and it is going to set of different individuals. So the total is same, right? So this income, the input, output, input plus transaction fee is equal to output. So that is the kind of thing, and then you have the transaction fee you can get, right? So initially how it started value, and now in fact people started using, and if you look at it, first time when $25 Visa was 10,000 bitcoins. Now one bitcoin is a few thousands of dollars, one bitcoin. Earlier $25 was 10,000 bitcoins, right? Or one bitcoin was like 4,000 bitcoins, but now it slowly has come down, right? So this is how it looks like. And by and large, bitcoins were used for negative purposes, as we see here, Silk Road and other things. You can buy cocaine or pornography, or a lot of these things you could buy using Bitcoin. And suddenly the cost has increased, as you see, December 2017. Maybe that was a time when 5 years ago, when I was asked first to explain about Bitcoins on a television interview. And that time when I remember 13 lakhs. And when I was telling 13 lakhs, people were shocked. But around 2021 August, 35 lakhs. And by November, December, it was like 70 lakhs. I will show you some slides. I think, yeah, it's coming up. So this was December 17th, it was 19 lakhs. And slowly it increased for a certain time. And then somewhere in April 14th it was 63 lakhs, and so roughly now it is 43 lakhs. So it goes up and down, and somewhere in the peak of November 10th 2021, almost a year ago, it touched about 67 lakhs, right? One Bitcoin was 67 lakhs, right? So, and then of course different Tesla, JP Morgan, MicroStrategy, Grayscale, a lot of these companies have invested, and I think MasterCard may slowly introduce cryptocurrencies as a payment method also. It will become a legal tender. Of course, India may not allow it. India may not recognize Bitcoin or blockchain cryptocurrencies as a legal tender, but they have not banned it as. And there were so many modifications which have come of Bitcoin, Ethereum, Litecoin, Zcash, Ripple, Dash, and of course our own Deshi Lakshmi coin also was there. Of course, not very popular. These are the present crypto coins in the market: Bitcoin, Ethereum, Binance, Tether, Uniswap. So different coins. So now, if you look at, there are so many coins that are there in this, right? Why does Bitcoin matter? It's basically because it's a purely digital cryptocurrency, and there is no central bank. So if like let us say if you have a 100 rupee note and it is spoiled or torn in the half, it got torn and phat gaya man lo. So you take it to a bank and then you do it. If no bank is taking it, you go to the Reserve Bank of India, and the Reserve Bank of India branch of that particular city or something, and then you can get that money, right? So that is how it is, and then it is a peer-to-peer network. Nobody maintains it. There is no central agency. There is no central control. It is running on its own. It's a peer-to-peer network, right? And then transactions are verified by these miners, who are called miners. Miners are the people who want to add the blocks. So people who add the blocks. So that's the whole process of what we look at mining. So these miners, when they add a block, those miners who are not able to add the block first, what they do is, anyway they also got the same result. So what they will do is they verify the others' results. This is a kind of an ecosystem which is created, and it's working fine. And those are the people whom you can trust. If suddenly all the miners one day feel that there is no use of doing mining, let's stop mining, let's close our office. So if all the miners stop doing their office, the blockchain mechanism will fail. But somehow the blockchain mechanism will not fail because many of the miners have so many Bitcoins with them, and they don't want it to fail. So they have to continue to create more Bitcoins and manage the whole show. But that's how it is, right? So it's a simple distributed ledger or a shared database. So that's what we can look at it. The only advantage that we look at it is the transactions that are logged onto the system are immutable. You cannot change them. So that is something that you can look at. So if you look at initially I would suggest this is a website that I want you to visit, andersbrownworth.com/blockchain. This gives you a very good understanding of the emulation of a blockchain, how a blockchain looks like. So I just took some pictures from that website. You can go, it's not a simulation, but it's an emulation. Emulation means you can see how the things are running, right? So this is an example. So there's some sentence that or some data that you type, there is a hash value, right? You can type different data. As you keep on changing the data, the hash value will keep changing, right? So you understand hashing. So I'm just leaving it. Blockchain uses secured hash algorithm 256-bit secure hash algorithm. Of course, there's a 512-bit hash algorithm also, right? So these are some aspects that you look at when we have these transactions, as I mentioned. So there will be a hash of the transaction. There is an input public key, that is a 32-bit key that you have. The amount of the Bitcoin that is to be transacted. There is a transaction fee that you will have, the addresses that are going to receive. So you can create an alias, and you can have 4 or 5 addresses. You can have 4 or 5 wallets. You can have 4 or 5 addresses. And obviously you can club all of them and send the money. So all these options are there, and you can create aliases for the same wallet. You can have 4 or 5 public keys or addresses that you can call it a 32-bit code. So like that you can use all those things and definitely transact different money, right? There are data sets which are called UTXO dataset, and of course it may be a little difficult for you to understand at level 1. But maybe I'll share the slides to the faculty, Vikas Tyagi ji or Samyavir, right? So I will, I will send them and they can take it forward, right? So they will share it with you, and you can go through these slides, because this is, see, for why I want to share the slides or why I want to share this information is I want us to explore blockchains. Many of us are afraid of cryptography. Cryptography is difficult. I also feel it is difficult, but see, we have to start doing. In fact, computer science was difficult. So when we started working on it, so now we are comfortable on certain aspects, right? So it is all about trying to give time and trying to work out things. Otherwise, it's a part easy. So there are two data sets which are maintained. One is called the UTXO output, and there's another thing. It's called the mempool. These are so now you can access these data sets, which you can use it. All the transactions are stored there, right? So whenever you want to spend Bitcoins, you can create a transaction and you can send it to all the peers. So whenever you are wanting, there are two ways how you can do these transactions. One is you can have a wallet, and in the wallet you make a transaction that I want, this is my address, this is my amount that I have, this is the address that I want to send some money, and this is the amount that I want to send. You enter and create a transaction and send it. So the app or the wallet that is there, it creates and links with the blockchain and puts your transaction, and it broadcasts to all the peers who are there, peer-to-peer network, right? So it goes to all the people who are connected to the blockchain. So now you may be asking, sir, how do I connect to the blockchain if I don't want to use a wallet? Obviously, you set up the software of a blockchain, or for the Bitcoin blockchain. For every blockchain, there is a software. So for if you want to set up Ethereum, you have Ethereum node, you have a blockchain, you have a code. For a Bitcoin blockchain, you have a code. So you have set up what is called Bitcoin Core. That is the software. You download it, you install it, and you set it up. And then once it is set up, you download the data set, right? So all the data of all the transactions happen till now you will have a copy of that. And that's a huge resource, maybe something like 1 TB now. So that 1 TB of data is good enough to do a lot of transaction details that you can look at, right? So a transaction is sent to all the peers. When a block is added, people take that set of transactions, create a Merkle tree, look at the previous hash, identify new nonce so that a new hash is created, which is less than a target value. And then if it is there, all these transactions are verified. When the transaction is verified, then the money has been transferred to you. You will receive the money into your account. So whenever you are verifying your account, you will be able to see that the transaction is added to your account. This is how things are made. So these are two data sets which are maintained. One is called the UTXO set, a file that contains all the spendable output that are available to be spent in a transaction. So all the transactions that are there, they are coming into an UTXO set. Second thing is you have a mempool. What is mempool? Mempool is a file. Sorry, mempool is a file. Mempool is a file that contains transactions which are received by peer nodes but are yet to be included in any block. So the unconfirmed transactions are in mempool, and those which are going to be spent, they have to be put in a UTXO set. So these two data sets are available to us, and you can go ahead. So every block is linked to the other block, making it a blockchain. So each block contains these following things. One is the previous block hash, one is the Merkle root, and one is the nonce. These three values will give us the present block hash, right? So that is something that is happening. The blocks are chained together. Every block new hash will be built on the previous hash value and the nonce and all the transactions which will give you the Merkle root, right? So a blockchain is immutable because any change in one value, one transaction somewhere you change, it changes the Merkle root. If it changes the Merkle root, it changes the hash of that block. If it changes the hash of the block, it changes the next hash of the next block, right? A hash of the next block, and so on. So obviously that whole blockchain will become inactive, and that is what prevents double spending. You can't have one Bitcoin and you can't pay to two different people at the same time. So that is something that is there. So basic understanding of Merkle root, it combines the hash value of transactions together till there is a singular root. So it is called the Merkle tree root hash. Basically all the transactions are summarized in a block. So you are actually trying to create a hash of all the transactions which are there in that particular block, right? So you verify the presence of a transaction in a block and provide immutability of transactions since the Merkle tree root hash will not match if the change is made to any transaction. So this is something that you can look at, right? So Merkle root is something like this. You have transaction 1, transaction 0, transaction 2, transaction 3, so many transactions. You take the hash of the transactions, then you combine them. Again, you take the hash of the transactions and you combine them. So if there are 1000 transactions, then 1000 become 500, 500 become 250, 250 become 125, 125 become 64, something 62, and like that. You know, it finally becomes one hash value. So that is what is called the Merkle root. Now that Merkle root is what is calculated, right? And then you create something. So what is happening? So there is a block number, there is a nonce that has to be calculated. Some transactions are being put here. The previous hash value, Merkle root based on this transaction, and the nonce value is calculated. That is what is using a mining function. If you look at the website that I mentioned, you can simulate this and see it, right? So mining is basically a process which is there. Now you can attack mining also, and there are a lot of work going on in attacking minings, right? So how are miners doing? Miners are doing what is they are solving a cryptographic puzzle. The cryptographic puzzle is now called proof of work puzzle. Proof of work means whoever is able to do more work, whoever is able to get the nonce value first, whoever is able to get the new hash value first, he is said to be a successful miner. So, and then what you need to do is to solve the puzzle, you have to try different values of the nonce, and different values of the nonce will actually give you the correct this value. So once that comes in, you can try to look at it, right? So the proof of work involves scanning for a value which is called a nonce, that when hash results in the hash value beginning with a number of zeros, right? So this is how a blockchain is created. As I mentioned, this is the website. You can visit this website and look at this sample example, and then you can see. So this hash value, the first block will have no hash values, obviously. This hash value is copied here, and this hash value, the transaction value in the nonce, will decide the new hash value. This new hash value will be based on the previous hash value from here, and then some transactions which will help you in getting the Merkle root and the new nonce value, right? Of course, it is difficult to change because there is an avalanche effect. As you see, one change somewhere will change the whole this thing. So change in the data of a transaction will change the hash of the transaction, will change the hash of the block, because here it will affect the Merkle root. The Merkle root will affect the hash will affect the hash of the block, and the hash of the block will affect the hash of the next block, right? So when you look at this immutabilities in the blockchain, so whenever one hash value, one transaction value is changed here, all the blocks will become, so the color here signifies that there is a change, right? So anyway, these are not important. Let me click. So this is what is the mining process. A miner, what he does is he takes all the transactions, if they are all valid, he bundles the transactions into a block, selects the header of the most recent block, and finds out the new block as a hash. Then he solves the proof of work problem, and when the solution is added, a new block is added. That is what is mining process. Now how does that done? So he proposes a new block, and for that he gets the header of the most recent block, the previous block hash is taken. Then he looks at a new block where he gets the Merkle root value, right? All the transactions are put in the block, and that Merkle root of all the transactions is taken. Header of the previous block is taken, Merkle root is taken, and the nonce is taken. You combine it and you get a new hash, and you check the new hash whether it is less than the target value. If it is yes, the proof of work is solved. If it is no, you go back and go for a new nonce. So this is a brute force problem that happens, and this is what you are solving, a cryptographic problem. And if you solve it, then you get a reward, right? And you are always also comparing whether how much time it is taking to get the new hash value. If it is less than time, then you improve the difficulty value. So this is something amazing that I can look at, right? And this is automatically done. Nobody is actually monitoring, but they're looking at the time. If there are more than 6 blocks which are created, then the difficulty value increases. So you can't create it to get a value, it will take some time. So usually every 60 minutes, 6 blocks. So every 10 minutes, 1 block must come. But sometimes later, what happens is it takes more time, because if some people are there, we will tell you some of the security attacks that happen and how the this mining is adjusted, right? So that's what we look at. This is a clearer diagram. You can slowly go through it when I share with you, right? The target value also automatically adjusts every 2016 blocks. There are roughly 2 weeks. That because it will ensure that a block is mined once every 10 minutes, right? And later, also one more important challenging thing as we look at the mining algorithms. So initially the mining algorithms were created so that one person will be able to create mine one block, one block. Like that, right? So, but then initially CPUs were used, later FPGAs were used, later GPUs were used, graphical processing units were used. Now, application specific IC, integrated circuit, application specific. That means the mining algorithm is created as a chip, and that is directly used and to solve the problem. So that is something that we look at, right? So ASIC is a microchip specifically designed to execute a hashing algorithm. So initially when I started working with blockchains, so and ASICs will take a lot of power. So when we looked at we try to design what is called an ASIC resistant mining algorithm. So this is one problem. So ASICs are created and they will give you faster results. But what happens is now you have to design a mining algorithm which will be resistant. So the Bitcoin algorithm may not be resistant, but the later on where you have the proof of stake algorithm, is the Ethereum mining algorithm. It is based on what is called ASIC resistant mining algorithm. So even if you create an ASIC, the ASIC will not be able to handle this mining algorithm, right? It won't break it, right? So that is something that you can look at. Similarly, you have an ASIC resistant mining algorithms which are there, which are called equihash and ethash and randomX. RandomX is for Monero. So these are the hashes that are there, and then you can have it, right? So the proof of stake algorithm, basically it came up quite recently. Of course, now it is almost 2 years old. But then the first phase was rolled out, and it was rolled out as what was called the shard chains, right? Instead of one blockchain, there are 64 blocks. So 64 chains running, and they are called as shard chains. Sharding is maybe you would have heard in databases, you would have heard about sharding. So proof of stake algorithm, the stake is important. Proof of stake is more important. Proof of work, whoever was done the work faster, he was given more preference. Now proof of stake is one who has more value with him, he is given more preference. Number of values that are there in the miner's wallet will give him preference, and the length of the time that the miner has held the coins in the wallet will also give preference. So that is how we went in, right? So the first kind of attack that was happening on blockchain, when we start the security aspects, till now I introduced what was blockchain, right? Now I am trying to look at what is double spending. Double spending is where we are looking at, I have 10 Bitcoins and I want to use the 10 Bitcoins to make 2 transactions. So same 10 Bitcoins I want to use to make 2 transactions, right? So I want, like, I am Gillen and I have 10 Bitcoins and I want to send it to Nader and Brian. I want to use the same 10 coins and send it, right? That is how it was possible. And this was successful as long as you could send it to 2 different sellers. Like you go to Amazon and then you have 1,000 rupees, but you want to buy 2 different items in 2 different transactions of 1,000 rupees each at the same time. Or maybe you are on Amazon also and you are on Flipkart and you are making 2 transactions. The bank will approve only 1 transaction. Only 1 can be purchased, right? So same case here, when you look at the when it does 2 transactions using the same Bitcoin, right? But these 2 Bitcoins can go into 2 different blocks, and the 2 different blocks may be verified at 2 different times. And one of the transaction is not correct will be found out later, and those transactions will not be approved, right? But it will take some time. In between, if the seller is so impatient and he sends out the product, right, that is where the attack can be successful. Otherwise, after some time, the blocks fail. So maybe sometimes the transactions move ahead because they go into different transactions, and as they move along, so suddenly it realizes that the transactions are not valid and the block is not added. So the block getting added is not confirmed till 6 or 7 miners will confirm that. So that is how it is preventing. So now what has happens? This is a case where this same Bitcoin is sent to seller A and seller B, but seller A waits for all these transactions. All the 7 or 8 people transacted. This block is added to the blockchain. Then the transaction is accepted. But some seller B, he doesn't look at this. Only 1 block is added, but he doesn't wait for the confirmation. He directly sends the product. Then he loses the money because after some time they find that these transactions are not valid and they reject this block. This block is not added. So that is how a double spending can be there, right? The next attack that we can look at on blockchain is 51% attack. The 51% attack is possible when a single miner or a group of miners take over 51% or more of the network's power, right? A hash rate is what we look at, right? The capacity to hash, the capacity to solve the cryptographic puzzle. Now, the cryptographic puzzle itself is a security tool, but somebody taking control over, if you can create consortiums and then you can try to attack. So, what you try to do is, if you have more power, then you don't verify the blocks, you add your own blocks, you allow a lot of double spending. All these things can be done, because tomorrow nobody can come back and tell we are removing all these transactions, right? Recently I heard that one blockchain, very successful blockchain, maybe you can search 2-3 days ago, few of the transactions were like this, were found this thing. They stopped all further transactions, all further blocks being added, they stopped. Now, what will happen to all the people who have saved money because they have converted their legal money into cryptocurrency? Now, those cryptocurrency has to be converted into legal money, but they said now, because till the problem of this attack is solved, we will not add any more further blocks, we will not make any more transactions. So all these blocks that have been added, all the transactions that have happened in this block are almost null and void. People are worried, but then because there is so much of money that is involved, so they will solve it cryptographically, make it more secure, and then again restart adding the blocks. Then again you can make transactions, then again you can withdraw the money, and then you can be safe. So this is something that you can look at. Otherwise, what will happen is they will fork a blockchain. Usually popular blockchains can be split. They are called forking, right? A blockchain becomes two blockchains or two chains, right? It can happen when there is centralization by mining pools which acquire more than 50% of the hash. All the people are coming together, they become a big company, and then they try to launch, right? And also, if you are working on a powerful software, a powerful blockchain, and you come down onto a smaller blockchain, like this blockchain is 40 lakh is the cost of one Bitcoin, right? One Bitcoin. Now then there may be some Bitcoins which may be only a few thousands of rupees, but the power to take over this blockchain may be very high. But if somebody has a power to create that and he uses it on a 50,000 worth of blockchain, he can easily do that. So this 51% attack is possible. A small proportion of the miners from larger coins to switch to a smaller coins will be easy. So that is another aspect. So it is very difficult for popular blockchains like Bitcoin and Ethereum, but it is cheaper definitely for the lower newer blockchains, right? So earlier there was an Ethereum hard fork. So Ethereum Classic, it suffered 3 times 51% attack in August 2020. People started wanting to take over, right? So usually attacks can be identified by unusually high rate of orphaned blocks. Orphaned blocks means there are some few blocks which are created, but then there is nobody who will continue it further. So the blocks will be dumped. All the transactions that are verified, all the blocks that are added, no money is given till the block is getting added and verified by 7 or 8 people, right? So 7 or 8 miners have to verify your block, then only your block will get added. So this is something that you can have, right? So of course, people started working on a blockchain called Dash, which uses a secondary validation called chain locks. So it prevents a block reorganization, but making it expensive for the attacker. He has to create a lock of the chains. So that becomes very costly, right? The first attack that I talked about was double spending. The second attack was 51% attack. The third attack I'm talking about is a selfish mining attack. What is a selfish mining attack? People are creating blocks. Suddenly, one miner created a block very fast. But then, instead of adding this block to the blockchain, what he did was he created the next block. By the time somebody else has created one more block, he has created 3 blocks, right? Because he had time. And suddenly after some time, he reveals this. Once this block is created, he reveals 3 blocks immediately he adds. So then as you see, you can't deny these blocks because this block is correct and the next 2 blocks are also correct. So when they look at this, who created this block first? Though these 2 blocks are created, this was later, but this is earlier than this. And this is earlier than any of the next ones. So these 2 answers would have come here, but they have already come here. So what would done? Immediately this will be declared as final and this block will be dumped. So this is actually a honest chain, and this is a selfish chain, but this selfish chain becomes the actual one. So a lot of times the efforts put by honest miners will be lost because the selfish miner is trying to do such things, right? The fourth type of attack is the DDoS attack, distributed denial of service attacks. This can happen, and competing miners, what they can do is they can add some unnecessary transactions. So people are verifying those transactions and all. Actually, the transactions are not there. The transactions are not valid. The block also doesn't get correct. So there is a wastage of time. So what they do, sometimes the competing miners, they take them out of the network by introducing some, they attack the system, or they attack their servers, and they are taken out. That is one aspect. The other one is they add a lot of fake transactions which are actually not there. So the fake transactions are verified. These people know that they are fake transactions, so they won't add it. The other person adds the fact transaction, calculates the Merkle root, and does all those things, and then he loses money. The next type of attack is called a network attack on the blockchain. So every blockchain, let us say this is the blockchain network. So when this user wants to visit the blockchain, he has to come to a DNS server. The DNS server will give the address of this blockchain. So what this fellow does is he poisons the attack, DNS poisoning attack. He poisons the attack, and he says when this fellow asks for an address, he doesn't give the address of the blockchain, he gives the address of the attacker network. So first he poisons the DNS cache. This user wants to request connecting to blockchain, so he gets a fake address. He doesn't get the address of this network, get the address of this network. So he makes this transaction. Then he actually user is routed to the attacker network. Here you are also thinking you are on a blockchain, but you are actually wasting your time and spending a lot of your resources on that. So these are another type of attacks. So the fake entry point nodes return to the user, and then they do that. So user could be routed to some alternate network rather than the actual blockchain. Another attack is called the Eclipse attack, which are all network attacks. So Eclipse attack is something similar to wireless sensor networks. Sensor nodes are there, so there are some malicious nodes. So what the malicious nodes do? The malicious nodes compromise the other nodes also. The honest nodes are also attacked, and they all become malicious nodes, right? So these are the malicious nodes, and they are also getting wrong information, so all become malicious. So this is how a network attack can happen, right? So that is how you can see that, right? So there are some privacy attacks. Now privacy attacks is basically every user has a if you have a wallet, the wallet will have a QR code like this, and then there is an address. This is a 32-bit address by which you know that. How do you know that this matters? When you want to ask your friend to send some money, you send a bank account. In Bitcoins, when you want to transfer, you will send an address like this, or you send a QR code like this. That fellow scans the QR code on his app and makes the transactions, right? So I will encourage you to create Bitcoin wallets, kind of free of cost, not very costly. You can do that. You can take those things, and then you can do that transactions, right? And you can see, maybe you don't have to invest lakhs of rupees, but you can also look at selling and buying Satoshis or Ethereum. Ethereum is slightly cheaper. Then there are other coins which are even more cheaper. So you can look at that, right? So these addresses are there, right? So and you can generate as many addresses as required, right? That's also possible, right? But then observer can use the transaction history in the blockchain to find out the topology of the network, patterns of the transactions, patterns of the users' interactions. So this is what you can try to do. So this can be actually calculated and find out. And based on this, they could find out where are the Bitcoin nodes that are created, how are the people connecting, and how are the transactions. Easily detect who is the person who is doing the transaction, right? So that is the kind of thing that can be looked at, right? So then there are privacy attacks also, which can be there. Privacy attacks are whenever you are making a transaction. Let us say here you have some Bitcoins and you are sending to another Bitcoin. So some amount is taken here and the other amount is returned back to you, right? So the balance is coming back to you. So whatever account these Bitcoins are coming back, you know that they are your accounts. Something like this, maybe you can understand, like this is your user's address and you are sending to a vendor's address. The vendor address is quite popular. He advises that please send this money. Like people have the bank address or people have the web address. Like that, people have the public address of the vendor. Vendor may be any company like LG or Apple or some of these things. So user sends. So you can also make a transaction you can look at the transaction and you can understand if they are making to Apple, how many people are buying Apple things, and what are the values that are there. So those things you can find out, right? So, and then sometimes multiple addresses make a transaction to a single address. By looking at that, again you can analyze that these transactions all point to a single address, and obviously it means that these all addresses belong to a single individual. So next time you can analyze all these addresses, wherever they are making the transactions, you can find out that this is a single address. I was just mentioning how this thing, there is a 4 Bitcoin here, it is sent, 1 Bitcoin is sent to the recipient, the 3 Bitcoins are coming back to an address. Here though you change an address, this original address is same as this address, because you are making a transaction of 1 Bitcoin and the remaining 3 Bitcoins are coming back to another address. So this address, again you are making 1 Bitcoin transaction, this is going to recipient, again you are coming to a change of address, but again you know. So looking at these 3 addresses, this address and this address is pointing to the same individual, right? This is a kind of privacy analysis which can be done on transactions, right? So a lot of illegal activities are done in a way that you can look at money laundering. You want to exchange money from one person to other person without any bank knowing it, right? A kind of hawala. So obviously you can use Bitcoins, right? So that is the thing that you can look at. Wallet theft, because wallet is a file and obviously it stores some credentials like public and private keys for a blockchain address. So if somebody gets into your wallet and steals, it's something like stealing your internet banking password. Is it difficult? No. But then once you know it, immediately you will try that somebody got to know it. So immediately you will try to block that, right? And then you can try to look at that, right? So that is the kind of thing that you can look at, right? Of course, this is blockchain 2.0. Then one of the thing that is very important is smart contract. Smart contract is you can program the blockchain. Smart contract is specific to Ethereum blockchain. Where you can program the blockchain. That's where a lot of these thing comes. So obviously you can have a trusted entity which runs this code, right? So Ethereum is one decentralized platform which is designed to run smart contracts. If you want to program blockchain, you can also program the Bitcoin blockchain also. But the Bitcoin blockchain can be programmed in the sense that the Bitcoin blockchain has what is called a script. The programming language or the programming environment is called script. So you write scripts and then you can work it out. But in case of Ethereum blockchain, you use a programming language called Solidity or another language called Viper. The Solidity is quite popular. So you write smart contracts. You can go to Google and just search for Solidity codes. You will see so many codes, and then you can write smart contract. Smart contract is where you can make the transaction based on some conditions, right? And then you can create smart contracts for storing digital certificates. You can store, maybe it can be used to store medical data. All these things can be which are trustworthy, and they are to be very confident, and you can't modify it and change it. And if you want to do that, so that is where you use what is called the Ethereum smart contracts, right? These are the documentations that you can look at, and there are editors called Remix. Remix is an editor which is created by Ethereum to handle Solidity. So you can look at some Solidity code. This is a Solidity code example. Now, why am I telling all these is because there are some vulnerabilities in some of these programming languages. Also, there are vulnerabilities. There can be vulnerabilities when you create any program, right? Here is a Solidity program, Sol program, coin.sol. This is a sample program here. But what happens is there are something which are called some bugs which come in when the code is written. They are called reentrancy attack. So the reentrancy attack is a code failure, right? So there is a function called call.value of the smart contract, and decentralized autonomous organization DAO is something which can be created, but there was these attacks, reentrancy attacks, which happened on smart contracts. So you can look at some of these smart contracts, and then $60 million was stolen because of reentrancy attacks. So these are small contract code with the DAO vulnerability and how that vulnerability code helps. So withdraw balance function, if you can run it multiple times, then you can actually remove all the money from that account, right? So these are some things, and then to trace the money in a Bitcoin is really hectic. You can't very easily do it. So that's something which you look at. Of course, it also helps in overflow attack or forcible balance transfer or DOS attacks, right? So so for that, what we looked at is we can try to build what is called privacy preserving blockchain. So there is what is called Monero is a good example for that. So it builds what is called pseudo anonymity. So and it helps. How does it help? is it uses something which is called stealth addresses, or it also uses ring signatures and confidential transactions. Let us see some of these examples, right? So one of the thing is unlinkability is what it provides. What is linkability? Alice makes a transaction, Bob makes a transactions to Charlie addresses. So people know that Alice and Bob are somehow connected to Charlie. So this is a privacy issue, right? So I don't want anybody to know whom I'm making transactions to, or who is making transaction to whom. Or if some people are making transactions to one particular individual, then all those people are linked together. So now what I will do, I will link Alice and Bob as people who interact with Charlie. But then unlinkability, Monero gives an option where I will create an address for Charlie. Bob also creates an address for Charlie. Both of us are sending to two different addresses, but these two different addresses are actually pointing to Charlie's address. Both output address belong to Charlie, but they are unlinkable by the network. When they see it, it sees two different addresses. So Alice is making a different transaction, Bob is making a different transaction, but both the transactions are actually going to the same address, but they are represented by two different addresses. So stealth addresses is one principle, right? A different destination address for each output is derived from one Monero address of an user. So only the owner of the Monero address knows. He uses what is called view keys to find that out, and then he can do that, right? So that is something that you can look at, right? And then nobody can tell these outputs are going to the same person, right? So the second aspect that we look at is untraceability. Now untraceability, there is a traceability here. Some of the transactions, they are going to some addresses, then these addresses are going to some other addresses, right? So what is actually happening is you are able to trace these addresses. The ability to trace funds held by the same person by analyzing transaction data. Charlie is getting money from some addresses are getting money from some transactions. So you are able to identify, you are able to trace through that. So what happens is Monero, what it does is Monero provides untraceability by using ring signatures. So what is ring signature? We'll try to understand what is ring signature. Ring signature is basically a format where, you know, there is a message here, I will sign. So there are three people who will sign, right? And there are three people, there are three keys by which you can verify, right? But when you look at it, we don't know who is actually sending the messages, because only one of them, Alice or Bob or Carol, only one of them is sending the message. Three are locking and three keys are required to unlock, but only one real participant. Others are called mix-ins. Mix-ins means they're just standing there, dummy. You can think of that, right? Mix-ins are output from some previous transactions we are using there. So those ring signatures are created to sign the transaction. So what actually happens is, so find some outputs in the blockchain with the same amount of X as the output A you want to spend. These outputs are called mix-ins. You can use up to 4 to 25 mix-ins. You can have 4 mix-ins or 25 mix-ins. You can sign the transaction using a ring signature. Now, what is a ring signature? Ring signature is used to verify that at least one user from inputs have signed this ring transaction. So we don't know who has signed it. So that is the thing. So there is here we have this real input is going. So X Bitcoin. There are 4 transactions with X Bitcoins. Previous transactions, others one, mix-in 1, mix-in 2, mix-in 3 are previous transactions. The real input is only one transaction. All these 4 transactions are clubbed together and sent, but we don't know who is the real input. So that is something that you have. That's called a ring signature, right? Then how do you do confidential transactions? Then you use a lot of cryptographic transactions. So what do you want? You see the money, you see the amount. So people are able to realize these addresses. Once I know if somebody's address, then I can easily know how much money he's having and what is the transaction. So these are all public, so it is difficult, right? So what you try to do, you have the ability to hide transaction amounts to provide financial privacy. So this is one of the first cryptocurrency to use bulletproof technology. So now these are all things which are actually happening. So you please try to understand bulletproof. What is a bulletproof? Maybe I will advise you to read some papers. It's called short, non-interactive, zero knowledge proofs. So these are used to create confidential transactions, provide the encrypted input and output for a transaction are given in this thing, and then without revealing any other information about the numbers, you're able to get it. So you have on this power R, where you will get the values of G and H, and then you can conclude. So initially, what is shown here is not a value, is not the transaction fee, but there is a some kind of thing. So it is actually built on what is called what do you say? It uses the transaction amounts are hidden. Transaction graph is still public, and but then it is only it allows public verifiability of a transaction validity, right? How it can be done? It can be done using this Pedersen commitments. So using these the kind of proofs that can be there. Of course, these proofs are beyond the scope of this lecture. So this is how the Pedersen commitment can be given. C is equal to G power X, H power R. X is the value to be obfuscated. X is what you want to hide. X is the transaction amount which you want to hide. So you put it in these values. R is a random number. G and H are distinct generators on the elliptic curve, as I told you. So R is the blinding factor which will hide the value of X, right? It is binding such that the prover cannot later come to another R and X that gets to C. So if you want to find out the value of C, C is what you will store there, but C is representing G power X, H power R. X is the actual value. So you will try to find out what is that thing. It is hiding such that the difficult to guess X from C, as there is another factor called H. So R is a random number. So if you know R, then H power R you have to calculate. Then that you have to multiply with G power X, right? And then G and H are distinct numbers, and G power X, H power R. So you have to break this code again. It is like an RSA algorithm which will break these two prime numbers, and then you get the value, right? So that is the kind of thing that you do, right? So this is how you can find out that you have this, and then basically Pedersen's commitment are homomorphic. So you can add them, C1 plus C2 as you look, G power X1 plus X2 plus into H of R1 plus R2, something like that, right? So this is how you can verify it. The proof is following. You can look at that, and then you also have what are called zero knowledge proofs. Zero knowledge proofs are based on these things, non-interactive zero knowledge proofs. NIZK is that what they can do. So they have this. Peggy has a value, and then he sends a value. So he doesn't know what is the value. So he sends a prove it. Then there's a challenge, and Victor knows that what is the value, and then obviously he is able to find out the value of X. So that is how a verifier is able to determine whether that value is there or not. So that is what is called a non-interactive zero knowledge proof of knowledge, right? So Peggy creates pi using X, R, and C. So G power X, C is equal to G power X, H power R, and then it sends a value C and pi. So Victor is able to check the value of pi, and he understands that X is having a certain value, and he is able to look at that, right? So basically, this is where there are so many other things which are going on as well. So as of now, this is where I would like, and I will want to share some information. Let me share some of the, yeah. So I will start with, if you want to start somewhere reading this. So there's a national strategy on blockchain, maybe a 1 year old, December 2021, right? So this is about 50 pages document, which was released by METI. There is a policy on blockchain, so you can try to look at that, try to understand how it goes, and look at what it is. Then, of course, blockchain and India strategy was released by Niti Aayog. It's a very popular thing that you look at. So this is a Niti Aayog document. This is also some 59-60 pages, and you can look at that. And somewhere in between, you have a survey paper, which is quite popular. You can go, this is a 30-page paper, which talks about different security attacks on blockchain. So you can look at that. So exploring the attack surface of blockchain. So you can read this paper. And recently, this paper is also online, obviously. This is by Cloud Security Alliance, top 10 blockchain attacks and vulnerabilities and weaknesses. So this is the Cloud Security Alliance paper, and this will be available online. So you can go and read that. If you don't get it, I will share these things. So this is recent 2021, last year sometime they have released this paper, and they have given a variety of questions and solutions. So Cloud Security Alliance is what CSA stands for, Cloud Security Alliance. And then you have some of these attacks which are there, which are quite similar. Some of them have discussed, some of them are yet to be understood. So these are some attacks that you can write, the valid security that I talked about, right? So you can look at some of these attacks, and then you can work out, right? So I have a meeting at 4, but then yes, I have 15 minutes of time for you. If you have any questions, I'll be very happy to answer the questions. Hello.
Yes, sir. Hello? Sir, I'm audible.
Yeah, it is coming very low. Yeah, no problem. Yeah. Hello.
Yes, sir. Yes, sir.
Yeah, yeah. Is there any questions? Otherwise, I'll show, because we have some time, I will show you some scripts. Maybe we can look at that scripts.
Yeah. Uh,
Yeah, I think there's some
Participant, there
questions in
is
the chat.
there is any query regarding this presentation, can ask. Otherwise, sir will show you some scripts or examples. Sir, you can continue.
Yeah, yeah. Yeah, I'm looking at the chat if there's any. Has the government come up with regulations with crypto usage? No. Crypto income is what government was interested. So they have put some regulations. So whenever you buy and sell bitcoins in a blockchain exchange, in a Bitcoin exchange, or any cryptocurrency exchange, there are so many exchanges like how you have stock exchange. So many online exchanges where you can get a buy and sell amount. So you can try to do that, right? So that is something you can try to do. And regarding regulations, we are not really confident. But then yes, I think the blockchain working group, or MIT, Ministry of Electronics and Information Technology, may be coming up in the recent time. It may come up with regulations on how crypto is used. As of now, they have not banned crypto usage. They cannot ban also, because it will be very difficult, because world around, if some technology is accepted and online transactions can be done. So obviously, even if you don't buy in rupees, you can buy in dollars. So you can go and buy dollars and then pay in dollars and then buy the cryptocurrency. So obviously, it's an online thing, right? So you can go to thing like pay. This thing is there. A few website where you can go and pay in Indian rupees and get dollars. Later, you can pay in dollars and get Bitcoin. So possession of Bitcoins is not illegal as of now. Regulations are not against that. But then, why should we be worried about regulations against cryptocurrency? We must be able to defend cryptocurrency. That, I think, is the biggest challenge. So tomorrow, I mean, the challenge that I would like to place before you is, please take the Bitcoin research or Bitcoin working seriously. Don't only look at financial aspects of Bitcoin. Please look at the challenges that is there. So try to look at that aspect, right? So that is an important aspect, that we must get hands-on technology. Many times we are afraid of crypto, or we are afraid of coding, or we are afraid of learning new languages like Solidity, Viper, or Remix. Some of these things, few people in India are now doing. Many companies like TCS, Wipro, and all, they have blockchain research groups, Infosys, and a lot of Indian companies have these things. And I think we don't have an Indian blockchain, to be honest, right? But many Indians may be there behind some of these blockchains which have been created, right? So you can just type mining algorithms in Wikipedia and you will get some 200 mining algorithms. So there is so many different cryptocurrencies which are running, and they are all competing against one another, right? And they are you can find out their values, comparing them with the dollar rates, and you can find out. Of course, many are not popular, but definitely the cheapest cryptocurrency will be few thousands of rupees, right? Like 20,000 or something will be one coin in the cheapest. But costliest thing, it goes to 40 lakhs. So that's a big. Right? What type of economic implication on cryptocurrency adoption? Economic implication is a lot of black money kind of thing can be generated. You can try to you accounts. Government will not get any accounts, because now with the digital technology, what has happened was all accounts are being tracked. the amount that you are receiving and sending, whatever you are buying, you are paying through. Earlier, you used to pay through cash. Maybe a good example is real estate, where people used to buy in black. They used to give the black money. Right? Black money is earned by corrupt means, using different mechanisms. Or maybe some of the people who deal with some businesses, you don't pay in the exact amount. You pay less or you pay more. Or land real estate business, they would never have the white transaction. White transaction means they would say the amount is 45 lakhs, but they will ask 70 lakhs to be paid. 45 lakhs will be paid through bank, and 25 lakhs will be paid through cash. There's cash is no account. But now, because of Digital India, the initiative of the government, we see that everything is now logged. Logged in the sense transactions are logged. So that is the implication that we have. Now, this thing can be broken because of blockchain. And if we ignore blockchain as Indians, we will be left behind. Because the world is now using variety of means, variety of modes of communication, variety of things. So I think some of these things which are disruptive technologies, blockchain is one of them, quantum is one of them. These are where Indians are weak. We are finding it difficult, and we are shying away. And I think it is time that we need to take it, face to face. We should not run away. We should take it head on collision, right? We have to do something like that. So I think that is where we need to look at. Please, my thought of sharing all this information, also sharing the slides and the PDFs also, I will send it across to you. You can read it. But then is what you need to look at. Yeah, there are some attacks that you are mentioning, like I think DeFi attack and the balancing attack. Yes. Now, what is needed is, of course, the kind of resources that you need to know. The second thing that you need to understand is how the attack is happening. Newer attacks keep coming every recently. So I was also mentioning there are 10 attacks that I mentioned on the CSA. This thing that is also, I think, a couple of months old, maybe 1 year old now already. So like that, if you look at it, there are so many new attacks also coming, right? And then there are new concepts also coming. One of the concepts I will share before I close is what is called an atomic swap. Now, when you do an atomic swap is where two different individuals have two different cryptocurrencies with them. They are on two different blockchains. You have an Ethereum and you have Bitcoin. He also has Ethereum and Bitcoin. You have Ethereum coins and he has Bitcoin coins. You want to exchange. You want to exchange Bitcoin to Bitcoin. You want to exchange Ethereum to Ethereum. But they are on two different blockchains. How do we do it? Right? How is it trustworthy? If I know one another, if we are two friends, then I will send money. You can send money later tomorrow. No problem. Even if you don't send also, I will meet you and take you later. But if you are not friends, we don't know each other. But if we are met on a platform, and the platform says, okay, you transfer this one, you transfer this one, we will do. But if there's a platform in between, the platform will say, you give me money. Like any wallet, right? You can put the money in this wallet and take out the money. You can transfer the money and he can transfer the money. But the wallet will take an exchange. But why should we do exchange fee when we both are two individuals and we are able to have, we have two different currencies, we can do it. So we can do an atomic swap. Wonderful idea, right? So I send the money on, because I have Ethereum, I will send the money on your Ethereum account. You have money in Bitcoin, so you send my money into my account. Because we know the conversion factor between Ethereum and the Bitcoin blockchain, we will decide, I will send so much, you will send me so much, and then you make the transactions. So whatever transaction I make will hold till you make the transaction. And both will be opened at the same time. That is how you can use Solidity code, like create a smart contract, or you can write what are called scripts, which can also be there. So just share some scripts. I will show you. Maybe you will find them also. Quickly, I'll show you some scripts. So this is how a script looks like, right? This is how a script looks like, right? Bitcoin locking script. So the programming language is called script, right? Then you have a script signature, which is there. So along with the hash, you put a script, right? And this will actually, this is an unlocking script, this is a locking script, and this is how you do, right? So if you look at, maybe if you, This is a kind of how the script, the entire script is there and the script is being executed, right? So finally, when the hash becomes 0, this whole thing becomes closed. Right? So there are different types of hash like this. So you have different script, pay to public key hash, and pay to script hash, like that, right? So there are different kinds of hashes which can go on, and you can try to look at how the thing goes. First these two go in, and then like that. So they are equal. Then again you check the signature, and they are again equal. Then you end up in a result as 1. So some of these scripts you can try to look at. And obviously after the scripts you have smart contracts which are used in Ethereum, as we talked about, and then you have hash time log contracts also which you can use. So some of these things you can look at how a transaction goes. So how an atomic swap can be done is what I was mentioning here. So you can write like that, right? So if there are any questions, I'll be happy to.
Any question, participants?
Yeah, I think it will take some time for them to digest. This is a long talk, and yeah, I will send you the kind of information. Yeah, it will take you some time to go through and understand and read through. So I think you will get it. Just in some time, you will be able to understand, right? So that is something that.
Okay, then thank you, sir. Your talk was very informative and knowledgeable, and I'm very sure student will get benefited and use these technologies in their research and in studies. So I am very thankful for all. Thank you, sir.
Yeah, thank you so much. I think Emmanuel is thanking Emmanuel. Good, thank you. Have a nice time. All the best. And I think I'm having another meeting at 4. I didn't realize that the talk is till 4:30. Otherwise, I would have shared these atomic swap also with you. But maybe some other time. But of course, I will send the slides. Right. The script part of the slides also, I will send it to you as attachment, so you can look at that. Right?
Yeah. Right. Thank you, sir.
The organizers will share the slides with you. Yeah. Bye.
Definitely. Okay, then thank you, participants, and next session will be tomorrow from 10 a.m. Right? So join on time. Thank you. And updated schedule is also uploaded. There is a change in schedule that you can see the updated schedule, right?